Now, okay, hello and welcome everyone. We're very pleased to have you here for our AI agent saga. First off, if you're new to GAP, if you haven't heard of us, I'd like to give you a brief introduction of who we are. We're a technology company committed to high quality results where we consult, design, build, and modernize software and data solutions. Today, we have Santiago Arango with a demo building called Building AI Agents with Azure, which is part of our AI agent saga, as I just mentioned. Santiago is an AI and cloud transformation architect with experience in AWS. He's also certified as an Azure architect, Azure and AWS AI architect, Terraform certified, and AWS Azure Developer Certified. So as you can see, he has a lot of knowledge about this topic, and I'm going to give it up to him. So now, Santiago, the floor is all yours.
Uh, Thank you, Camilo, for the introduction and welcome everyone. It's so good to have a good audience today. So today I'm going to share a little bit of that knowledge, especially for the Azure ecosystem. And in this case, we are going to be talking about the AI Foundry. This is actually let's say one of the Azure services that have been modernized recently. This service has been modernized recently because some time ago this used to be known as the Azure AI Studio. So back then, the Azure AI Studio was mostly focused to create custom vision solutions, some custom solutions for text as well. But when we speak about this fragment, maybe 1 or 2 years behind, it wasn't that advanced as it is today. So from that change, more or less a year ago, the Azure AI Studio modernized itself to be the AI Foundry. So as the name suggests, this is going to be the place on Azure where you are going to encounter everything that is related to AI. On this portal, you are going to see all the tools that you need to create agents, to use LLMs and deploy the LLMs too. You will be able to fine tune the models. You will be able to do a lot of things that give you the full capability to deploy agents. So you will be able to streamline the whole process of execution. At the same time, the Foundry make everything together into a single place. Because not only you are going to have this capability that we already seen for the LLMs and many other services like that, but we also are going to encounter many other capabilities and additional services that I'm going to give a quick summary later today. So this demo today is to give like an overview of the current state of the art of the AI Foundry. Then we are going to see how to create an agent on the Azure portal. We are going to explore the most common tools that we can attach to an agent and see them in action too. And at the same time, we are going to see some snapshot of code too, so you can see how the same things that we are going to be seeing on the Azure portal are going to be easily implemented of the code perspective too. So starting from the Azure AI Foundry, I call it this to the rescue because this is going to give us everything that we need to have in order to be able to deploy successful AI applications. In the Foundry on Azure, we have everything related to from the starting layer, which will be the models. This is something that is very likely you already heard and seen in other places like GPT 4.1, model from Mistral, and Facebook, and many other providers. The Foundry actually takes together all those important models and centralize everything to you in a single place. That means when you would like to deploy one of these existing LLMs, you don't have to have an account on OpenAI, you don't have to have an account in Hugging Face, in here under in Meta too, but actually you will have everything on the Azure side. At the same time, this is going to centralize everything. Not only the deployment, the management, the rollback-based access control for the API too, and many other security things, but at the same time, it's going to centralize also the billing very easily. From here, you will have all the usual capabilities that you see on the Azure services. You will be able to split the AI Foundry in multiple projects, so the billing it will be easier to manage. Also, as the name suggests, if you have multiple projects, you will be able to easily handle those solutions into isolated components. Each project will have its unique models deployed. All the different projects inside a particular AI Foundry deployment can share the same resources too, and as many other examples. But this is just like the initial thing or the initial layer for everything. From there, we have the AI Foundry agent service, which is actually the core of the AI Foundry. Why I call this the, let's say, the core services in here? Because you will have the capability to take any model that you deploy on the Azure AI Foundry, and you will be able to extend that model to fit your business requirement. Just as a very quick example, when we work with LLMs, they are usually very general. So you can ask them a lot of questions. They know a lot of things about particular domains. But eventually, when you start asking questions, the answers start to be like different. They don't usually match from the previous question and change a lot. So deploying an agent gives you a facility to change or actually improve those things. Because instead of having an LLM that knows a lot of things, you will be able to centralize your LLM, set up like a, let's call it a safeguard into that. And it's going to be a specific for some particular topic, knowledge base, or just to try to solve one particular task. The agent service, as we are going to see later again, is going to give you the capability to include many tools. You will be able to compile and execute code. You will be able to look up into the internet for detailed information. You will be able also to connect to many Azure services and provide extended solution, which is actually a huge plus. You will be able to connect to things like logic apps. You will be able to connect to Azure Functions too, to Azure Search and many other services to expand the capabilities of the agent service itself. In here, you will have also the capability to make your agent even more specialized if you would like to be, if you would like to have it. For example, you can leverage the Azure Machine Learning, which is another completely separate studio from the AI Foundry, and there you will be able, for example, to fine-tune your model working together with the AI Foundry in case you want your model to be more specific. For example, if you would like your agent to or your LLM to have the capabilities to answer questions based on your business domain, or have the capabilities to know some information that is actually not open to the internet, so by default the LLM doesn't know it, you can do it in there too. You can expand the capabilities also with machine learning too, adding extra capabilities to the agent, like additional processing, connecting it to many other services too, using pattern design and many other things that can add to your agent too. Plus, you can take advantage to the other services that we are going to speak in a moment to make even your services more smarter and more capable too. And not less than any other Azure services, you have full capability to have observability. You will be able to keep a full trace of everything that happens on the Azure side. So that is something that sometimes we lose when we move to external or third-party providers for LLMs and agents too. Azure is going to give you the capability to know how many tokens your LLM is processing, how much is actually costing that. It is going to give you feedback on how to improve the performance and the cost usage of your model too. But besides that, you will have all the security layer that you usually encounter on the Azure services. Traceability of who and from where the requests were made. Any unexpected request will be traced in there too. Let's say someone is trying to use your agent or your LLM to ask for information that it should not should be asking to, or maybe trying to get contact they are not should be trying to reach out to. These kind of things are going to be accessible and usable from the Azure portal. Then, outside of the context of the iFoundry, you will be able to integrate everything pretty easily with other services. You can deploy infrastructure into Kubernetes services, app services, Azure Container Apps, Azure Functions, and many other services. Another good thing is the Azure AI Foundry merged very good together with things like Copilot Studio, Visual Studio, GitHub, and of course the SDK, which is available as it is today in .NET, Python, and Java too. For any other programming language, you can leverage to the REST API, which is fully usable in any programming language that can provide an HTTP client. Now into mentioning to that, one of the good things that we can extend from the Foundry, and when we speak about models too, it will be the capability to integrate things not only with Azure services, but extended services from other providers that are present on the Azure ecosystem too. For example, mostly everything that you see on the OpenAI service on directly on their platform, it will be available on the Azure side. Vector stores, document chunking, vectorization, multiple models, a lot of models from OpenAI. All of those things, assistants, agents, and all of those are going to be fully available on the Azure portal too. Also, it's going to give you the flexibility to include content safety too, in case you want to restrict the content the LLM can produce and can give output to the user too. And at the same time, the information that the model can take out and filter that information before it causes any harm too. Then again, you will have capabilities to evaluate the quality of your model. You will be able to customize your agents, model assistance on deployment pretty easily too. Very important in the enterprise ecosystem, you will have the capability to have full governance of your LLM. That means not only you are going to be able to secure your agents and your deployment with the Azure ruling, but also you will be able to protect your infrastructure on who can access what, will be the level of permissions they can access. And also when you are working with third-party companies or your clients, you will be able to guarantee and give the capabilities that the data is being fully secure. It is not being used for any additional training or as part of the output of the model too, and also give you full monitoring of everything that is happening on the ecosystem too. Additional to that, you will encounter on the AI Foundry mostly all the foundational models that we already see and around. Plus, many other open source models are actually available too on the AI Foundry, mostly from day one. And also, you will be able to see models that are specifics for task. For example, we already know there are LLMs that are capable for answering questions back, providing information in text summary too. But at the same time, you are going to encounter models that are experts, for example, to process and create audio, and other ones that will be able to understand speech and natural language too. And even models that you can make a request and you can produce video using those models too. All of those are actually available too on the AI Foundry too. So like I mentioned, we will have the capability into these components to have models, agents, and also to do fine tuning to the agents. So with that, we can explain a little bit in let's call it in a quick overview, how an agent works. So the first part that we need to have, it will be an LLM or a model deploy. That model could be GPT 4.1, it could be GPT 4.0, it will be a model from Mistral, another from Hugging Face, from Meta. There are many models that you can choose to. Of course, you need to choose the model that suits more to your use case. Maybe you will need something that is pretty quick to answer, but it doesn't provide as much details as other models. Maybe you would like to have a particular model that maybe it's better to process code and produce output code than many others. Maybe others that actually have full reasoning when asking for detailed information too. So that will be the starting point. After that, here it comes the creation of the agent. So that model that you choose to is going to be the initial layer or the heart of the agent itself. Because the agent at the end is nothing more than an isolated unit of context that is going to be working in a specialized set of instructions. So let's give an example. Let's suppose that you are working in a company that plans travels for the different users. You could have one particular agent with a very particular task. It will be to take a look into your APIs, maybe retrieve the cheaper flights or the cheaper travels that they have available on list too. And the user will be able to request that information using natural language. So that would be one particular task. You could have another agent that maybe can give you like a quick summary of the best destinations, maybe for the summer in South America, maybe in North America, just like give you an example. But the most important thing is that the instructions and the things that that agent needs to do need to be precise, concise, and detailed as possible. So the context of an agent is going to be as good as the quality of the instructions that you give to the agent. If you give too broad set of instructions to a single agent, it's going to cause or is going to be more prone to produce a unexpected outcome. Quite the opposite, if you maybe give like a short or very small context, it's not going to give like the desired output. So you have to find the right balance to give like a single task into particular agent between giving them a multiple task. So that will be the instruction set. There, taking advantage from the AI Foundry too, you will have the capability to connect many other components to the agent itself. So for example, you can ask it to have a file search of a code interpreter, a function calling the Azure Search Service, and many others. As an example, let's go back into the example of the traveling agent. So this agent that is going to provide, let's say, feedback about the information of the best destinations for the summer, you can feed them PDF documents with the different travels that the agents thinks actually suits better for the client's team. And when the agent tries to recover the information that the user is actually asking to, he can go without any manual request from the, let's say, from the developer or anyone else, and take a look into those documents and find the most meaningful information based on the user question that has been already answered to. A pretty good example of function calling is let's say that you would like to take the request that the agent takes, and before sending back the information of the traveling to the end user, you would like to maybe develop some particular code, go into let's say into one database, retrieve the historic of the different trips that have been booked recently, maybe the most popular ones, and use that information to ask the agent to structure a more proper response. This is some of the few examples of the things that you can do to connect to an agent. Now that you have all the things, let's say, stick together to your agent, the instructions, the model, and also the tools that you would like to have, the next part, it will be to create a thread. The thread is actually pretty easy to understand. Let's suppose that I have deployed an agent into a website that all of us in this call we can access to. When we open the browser and we ask a question to the agent, for each one of us, we will have a unique thread. I will be assigned a unique thread, and each one of you also will get a unique thread. That thread, it will be how the agent is going to trace up the conversation that you are having with it. So that way, it will be able to answer the next set of questions, keeping the context of the previous conversation too. The good thing is that the thread is not only a historic of messages too, but also contains the historic of the tools that already have been called to the agent too. So if eventually on the previous call the agent already look up into the file search, he can use that information again, or he can keep the context of the information that has been already retrieved too. And the thread, it will live as long as the conversation lives and actually is being stored too. From here, let's say the process actually start. We call it on the Azure AI Foundry SDK a run. The run is going to be that place when we keep a conversation active with the agent using this thread. So we can keep asking questions, and the run takes my message and sends that information back to the agent, and the agent sends back that information to me. So this is usually what is known as a run. From there, I can keep the process as much as I like. I can keep processing more messages. I can just get the latest message, and I can increase the context of the agent using the SDK or the portal too. So one of the good things about the data tools is that we have a bunch of tools that are actually going to give us let's say, a upper hand when we are working with data. So as an example, we can feed information to our agent from private feeds. For example, that will come from the Azure AI search, for the file search, and also from the Microsoft Fabric and many other services that provide data from the Azure portal. For example, let's say your company have a very important private information that is only intended for internal use. Of course, since the standard LLMs that we have access to, usually they don't have access to this private data. What you can do is to use a service like the Azure AI Search, the file search, and one of the others, in order to take that meaningful information for you and connect your agent to that information. So at that moment when you do that, your LLM, your agent will be able to use that information to obtain the right context and enhance the response of the information you are asking to. But at the same time, having public information is actually pretty valuable too. So on the agent side for the Foundry, we will have the capability to connect, for example, to Bing Search. So that way, our agent will have the capability to go out into the internet and request information in real time. At the same time, pretty similar, you can connect things like a trip advisor just to retrieve information about trips and anything related to tourism too. You can even use external services like Morningstar to retrieve like more official documentation or technical documents from say from college, from research, from investigation, and many others. Together with the private data, you can use the AI search and also the file search in order to make the unstructured data meaningful to you. Document, images, anything like that can be become very helpful for the LLM. As an example, the Azure AI search can take images, extract the description of that image, and also use, for example, OCR to extract any text context from the image. That information will be stored on the Azure AI search. So let's suppose that you upload an image of, let's say, a particular trip to Miami. When you send the information to the Azure AI search, this one will have the capability working together with the OpenAI services on the Foundry too to analyze your image, extract a meaningful definition and description of that image too, and also extract any text from it. That information will be safe in there. So eventually you can go to your agent and you will have the capability to ask questions about Miami, and he is going to be able to find the information from that image and even reference that image back then too. Do we have a question, Camilo, if I notice correctly? Or okay, I think okay. If anyone has a question, you can post it into the chat and Camilo can let me know. Okay, and of course, working with structured data, this is not also away from the reality that we have. We have also Microsoft Fabric and many other services like SQL Server and many other services from databases that you can easily connect to just to retrieve information from the agent. So as you can see, using the Foundry and the agents, you will be able to extend those capabilities pretty easily. Now, here it comes something that is pretty appealing, not only for the business, but also for the developers too. Here we have the action tools or the more advanced tools that can actually make our agents superheroes. The reason for that is because all the tools that we spoke in the previous slide are actually pretty helpful to provide data, answer questions, summarize information, but eventually we would like to do something more advanced. Here are a couple of examples. We have the deep research, which is an advanced implementation of the Bing search. The deep research, which it is going to be very likely you are already familiar with it. The agent takes a particular topic that the user requests, goes out to the internet, do, as the name suggests, a deep research, try to grab all the most meaningful information from the internet, and after that it creates a very well-structured summary. So we have the capability to include that too. Now let's say in the greatest extension, we have the capability to connect things like Azure Logic apps, Azure Functions, and function calling too. This is the place where the developers actually can shine a lot because they will be able to orchestrate more complex things using Logic apps, which became pretty popular in this kind of implementation because they allow to connect many services pretty easily. Now, when we need to have something more specialized, you will have the capability to connect Azure functions pretty easily too via the code. And also you will be able to create something that is function calling. And this is actually one of the strongest players in here because the function calling is actually allow the developer to write any code they would like to write and allow the agent to make requests to that code. So let's suppose the developer needs to create a complex method where they need to make a request to multiple databases, retrieve the information, maybe parse that information into, let's say, XML, just to give like a crazy example, and give that information back to the agent. The developer will have the capability to write that code and send that information to the agent back to provide a meaningful information. Now here it comes something very important too. It will be the Open API aspect. And this is actually something pretty cool too. Why? The agent will be able to make a HTTPS request on your behalf without writing any code, any additional code besides the API. So going back into the example of the traveling agent, let's suppose that we have an API that already retrieves the last, let's say, top 20 most popular destinations on 2025 or the last quarter. So you can ask the agent, I would like to know which are the most popular destinations as it is today. Natural language. The agent will be able to kick up a request to that API internally, get that information back, and prepare the information in a nice formatted way back to the user. So as you can see, you will be able to call APIs pretty easily. The good thing is that this is not only limited for GET requests. You can actually post requests. You can actually patch information into the server too. So you can manipulate information on behalf of the API too, and many others. Of course, we have MCP tooling. You can write code connecting one or multiple agents together, and you can connect your agents to multiple MCP tools locally. So this is also pretty common too. You can connect multiple third-party services or other Azure services on the infrastructure too, and you can connect to your application MCP to Visual Studio Code or any other tool that takes advantage of this protocol too. And one that is becoming very popular also the last few days is the browser automation. Azure presented a few days ago the computer instances agents, which allow the computer to deploy agents that have access to your machine. Of course, this need to be used with a lot of attention because the agents will take a screenshot of your computer, the screens that you are working on too. But eventually, for automation and understand it based on images too, this is going to be a very powerful tool. As it is today, it's on preview state, but it's actually fully usable if you would like to test it too. Now, before moving into some of the demos that we have into the Azure portal, I wanted to make a couple of important mentions that we have that also feed up on the AI Foundry. Like I mentioned already, the Azure AI Foundry mixes together all of the AI services that Azure had in the past and the newer ones that they are been launching during the last 2 years. Additional to the AI search and the open AI that I already mentioned too, we have things like bot service, the content safety, custom vision, face, language and speech and translation and video indexer and many others. The advantages of all of these services is that you can actually use services that are specialized into something else and you can enhance the experience or augment the implementation that you already have. As an example, let's say you want to extract meaningful information from a document, maybe from an invoice, maybe from a legal document, maybe from a statement of work or something like that. You can orchestrate your agent to call the document intelligence, extract all the meaningful information from the document to send it back to you, to the agent then, and the agent will be able to prepare the output for you. And you can easily orchestrate many things. Let's suppose your agent takes an input of an image. You can use the content safety just to make sure the image that the user sent doesn't violate any particular rules of your business. And if everything goes well, he can send that information back to the to the custom vision. Let's say the custom vision extracts some metadata, some basic information too. You can use the translator to translate that metadata, that information into multiple languages, and after that you can send that information back to the agent to summarize. Just like I give it a strong example. Also, there are some services that have been retired. I just wanted to mention those, not because I would like to encourage you, of course, to use them too, just to keep them present in here, because if you eventually have to choose between one service or the other, be very careful of what you have to choose. For example, instead of using the Q&A maker, the best option today will be to use an agent, an LLM feed with the right information to do so. If you would like to use language understanding, you have also the LLM, the agent deployment, the text analyzer, the speech analyzer, and the translator to replace these kind of services. Just a quick mention of those. Avoid this and always make sure to move into the ones on the previous slide. Okay, let's move into the demo. Give me a sec. Having some problem with my keyboard. Okay. Let's see. So when you are working with the Azure AI Foundry, you are going to be presented with a very specialized place. So let me show you. So in here you have the AI Foundry. This is the main portal that you are going to see on the Azure portal. But this is just like let's call it the scraps, because nothing funny happens in here. This is the place where you will manage your resource as many other Azure services. You can give it a name. You can choose whatever region you would like to deploy it. You can choose security configuration, public connectivity, type of authentication. Very straightforward stuff that if you're already familiar with Azure too, it doesn't change too much. The good things happen on the other side when we are actually truly on the AI Foundry. So for this demo, I already prepared a deployment for the AI Foundry. So let's explore the meaningful place for the portal. So now that we are here on the AI Foundry, we are in the right place where we need to be. So in here, you will be presented with all of those things that I mentioned throughout the slide. So let's take a look. The first things that we are going to encounter in here, it will be all the models that we have deployed. So we have all the models that we have in here. All of those models are actually fully usable by any agent as they are today. Just keep into consideration that not all the models are actually usable for all the agents. For example, some models are actually specialized to be used in text agents, another ones for image, another ones for video. So just keep that in mind when you choose the right model too. Just to give you like a quick display, when you choose to deploy a base model, you will see that this is actually pretty easy. On the left panel, you will be presented with all the models that you have available to deploy to. So if you take a look, you will have the capability to have things like most of the GPT models. You have a couple of 3.2, code meanings, some for images too, chat completion, and you have many other providers like I mentioned before, Phi, Mistral. You will have Embed too, you will have DSIG too, and many others from other providers too. Once you choose the model you would like to deploy, you just need to click deploy, and that is going to create the deployment to you. That simple. Maybe after 1 or 2 minutes, you will be able to connect to your agent, sorry, to your LLM. You will be given an endpoint and also a key where you can connect to using your code. Also, as a best practice, remember to not to use any keys to connect to the services at this rate, but instead always have a preference to use RBAC authentication. So only the right people will be able to consume those models, and no keys can be exposed to the internet too. Just keep that in mind. It is actually a pretty good practice. So this is actually pretty straightforward. In here, we will have the playground. So let's take a look in here. So the playground, it will be that particular place where you can test your LLM without making a compromise of those things. So let me show you. So let's try the chat playground. This is very straightforward. But the thing is that you will be able to choose from one of the models that you already have deploying here. Let's say I would like to go with a GPT 4.1. I can give it a particular set of instructions if I wanted to. And also, like I mentioned, we have the capability to connect data pretty easily. We can connect things like Azure AI says, we can connect to the blob storage, we can connect to Cosmos, Elasticsearch, and even the internet, or maybe you can provide your own files in case that you want to do that too. We will see that later. But in here, this is pretty straightforward. So I can ask him, what is Azure Cloud? This is going to behave exactly as the many other models that we already seen on the internet. We are actually public to use. But this is going to give you the capability to understand what actually you are deploying and play with it before using it in a more advanced scenario too. Like I mentioned, you have the capability to play with video, images. Also, you will have the capabilities to play with audio, language, speech, and other services too. The playground is going to give you like access into those things that you would like to test. This is a pretty nice example of the video playground. If you have a model, a sort of model deployed, you will be able to test this out pretty easily. So you can use a prompt in here. You can give it whatever configuration you would like to give to the agent to, and eventually it's going to give you a video output as the ones you are seeing in here. This is just a quick set for examples. This one, for example, the prompt was is a meteorology chart with the prediction over Australia, just like to give an example. At the same time, you will be able to play with images too, audio playground, and speech too. It doesn't change too much, so I'm going to move into the next part, which is going to be the agents. Okay, so like I mentioned during the slides, you will have the capability in here to create agents pretty easily. So using the Azure portal is actually pretty straightforward. So if I choose to create a new agent, it is going to create one for me with a random name, a random ID, and it's going to choose one of the models that I have by default. But I can change it by one of these models that is actually available for me to use in here. So let's say I would like to use 4.1 mini. In here, I can give it proper instructions in case I want to give it like a specific task. And this is actually one of the main ideas to actually use agents. Instead of letting the LLM to answer the question whatever it likes to have, you can provide guidance in here and even safeguard the information or the type of questions that you would like to ask in here. So I can tell you, okay, you are an expert on Azure Cloud Provider. Answer any questions, giving details about the cloud thing. Try always to mention the advantages of Azure over other cloud providers. So this instruction is going to help out the LLM to produce a more meaningful output. So then again, I can go into the playground too. And in the playground, I will be able to start asking those questions in here. So I'm going to asking, okay, what is Azure event hubs? So he's going to give you, of course, a summary of the question that they asked to, but you notice something pretty important. It already includes the advantages of using the event hubs over other cloud providers. So using an agent in here gave me the capability not only to give it like a set of a specific construction, but also give me on a natural language capability to manipulate the output of the message that it has that is going to provide. So let's see another quick example. What is Azure Cosmos DB? So then again, as you can see, he answered the question that I asked you, but also provide the context that as a owner of the agent, I gave the instructions to. So if I decide to deploy this agent to the internet, to a web application, so other people can consume them too, it is going to be very high likely that it's going to see the same output. It is going to answer questions about the Azure cloud. It is going to provide the advantages over other cloud providers too, and give like a couple of examples of the, let's say, of the different of scenarios that we can have. Something also important to mention in here, if you go back into what I mentioned at the beginning, as you can see, we have a thread in here. So this particular conversation that I started in here, it is actually a unique thread. All the conversation that I'm having with the LLM or the agent from the beginning is actually being traced by the agent itself. So this is actually a pretty good thing because he keeps context of the thing that I have been asking to on the past too. But remember, there is a limit into that. It is not like the agent or the LLM at the state of the art as they are today. It is going to remember everything. But it's going to remember the most meaningful question, the most meaningful answers to, and the more recent ones, what usually actually applies to. But of course, keeping a thread is going to give, let's say, a good control of the context that we are actually using to. Another good thing that we can do on the Azure portal too, when we are doing this for the sake of experimentation, is that we can see what happened when I made a request to my agent in here. So as you can see, this was very, let's say, very straightforward. It took an input and took an output. But eventually, when we move ahead with the different demos, we are going to see how we actually interact with, let's say, with external tools and actually how enhance the behavior of the system. Now, before moving into the, let's say, into the next part of the demos on the UI, I want to show a couple of things that we are going to see in action on the already some agents that are already prepared to for this demo. So as you can see on the agent structure, you will have the capability to connect knowledge source, actions, and also connect agents to. Let's start with the knowledge. Here on the Azure portal, as you can see, you will have the capability to upload local files, use the Azure AI search, use Microsoft Fabric, SharePoint, Bing, in deep search and standard mode too, TripAdvisor and Morningstar, like I mentioned before. When you connect one of these services directly to the agent itself, he is going to use this information to feed itself when providing an output, as an expected output. So we will see that in a moment in action with Azure Search. Here also on the actions panel, we have something pretty good too. Like I mentioned before, we have great things like the code interpreter, we have the OpenAI 3.0 specified tool, and the Azure Logics too. Christina, do you have a question?
Christina, I just allowed you to talk if you want to say your question.
Christina, you're muted. In case you are talking, you are muted. Okay, I'm
Well,
going to.
in the meantime, we do have a question in the Q&A. It
Yep.
says, would these agents work in Azure DevOps and integrate with GitHub Copilot?
Okay, that is actually a pretty good question, and indeed you can use them in there too. So you can include any of the agents that you deploy to in any place that you would like to have them. Those places like the Azure DevOps platform, the Azure SRE agent 2, and GitHub Copilot 2 are actually two options. One of the advanced scenarios that we can use with the Azure AI Foundry it is exactly that. You have the capability to create custom copilots and deploy them into your ecosystem too. Or in case that you want to set them up as a MCP protocol, you can do that too. Yes, you can. Indeed, you can. Okay, Christina, did you have a question, or if you maybe have a problem with your microphone, you can post it into the chat. Okay, I'm going to follow up. Camilo, just let me know if maybe she reached out.
Okay, will do.
Okay. So following up in here, we will have the capability to include things like the code interpreter, which can take, as the name suggests, code, and it will be able to answer questions based on that code, produce new code into that, and produce meaningful information from the output of that. Here you can also connect a OpenAPI 3.0 specified tool. So you can use the schema provided by OpenAPI, or as maybe is also well known too, even if it has been deprecated, Swagger too. You can use the spec version to import APIs in here and make a request into those. Also, you have the capability to connect it with Azure Logic apps. And like I mentioned before, you have the capability to use custom function and Azure functions too. And the last scenario before we see those things on action, it will be the connected agents. And this is actually a great scenario to have when you are working with enterprise applications. And this is actually pretty easy to explain and to understand. When you have a very complex and unique scenario that you would like to solve, maybe having like one particular agent to solve everything is actually not a good idea. But instead, you create a smaller agent with particular fields that they can reach out pretty easily. So in the front of the application, you could have one particular agent that takes the input from the user, and that agent can send the request to another agent based on the user request. If we keep up with the example of the travel agency as an example, let's say that we have an agent in the front that is let's say, the traveling agent. When the user requests some particular information, let's say to travel to Miami, this first agent could be connected to another agent which retrieves information about the flight. So when he notices the intent of the user is to understand the trips to Miami, he can send the request to the other agent, and that other agent can take the information to the travels to Miami and send the information back to the agent. The main agent also can send the same request maybe to another one to extract all the more meaningful places to visit when you are traveling to Miami. So as you can see, the request went into a single agent, but that agent sent that information to many other agents. And at the end, that agent that sits on the front of everything is the orchestrator. He takes all the information given by the other inputs and process that information and give that information back in a meaningful way to the end user. So connecting agents is actually pretty harmful and pretty, let's say, flexible in order to achieve high quality outputs too. Okay, so let's see a couple of examples that I just mentioned in here. So let's see this first one on the playground. So this first agent actually has something very particular. As you can see, it has been connected to a particular index in the Azure search to answer questions. This index it is actually fed into information about Blazor, the framework from .NET to deploy more web applications. So I can ask him questions about the best practices for Blazor. So I can ask him to use this index to provide information. So in the instruction, I can ask him to use the Blazor index to provide answers about Blazor to the user. So I can come in here and ask him, what is the best way to write code on Blazor? Remember, the agent will have the capability to choose to use the tool or go outside to the internet in case he actually has the capability to do so. In this case, since of course the LLM already have base knowledge on Blazor, and I already fed some information from the Azure AI, from the Blazor index on the Azure search, it is going to use all that information together to answer your questions. So take a look. He already gave me a couple of naming conventions, component structure, and service injections, and many other things. And all this information that had been included on this practices result, it is because this information has been fed into an Azure Search Index. And as you can see, as part of the output, it's telling me, okay, all the information that I gave you in here comes from these documents too. So that will give the capability to the person receiving the answer to understand where the information came to, and maybe eventually refer to those documents too. So it uses these the coding standards MD and also uses these resource codes MD in order to provide the answer to the user. So this way, I gave instructions that are fully specialized into Blazor that are maybe not present on the internet and maybe are more specific to the way how my company actually writes the Blazor code. Now, if we move into the next demo, this is actually a pretty good one too. We are going to see first the connected agents. So we are going to have the news agent. This is going to be the agent that is going to sit in front of everything. But if you notice, this agent is going to be connected into event agents and a weather agent. If I take a look into each one of these agents, they will have unique instruction and a couple of things to mention in here. The event agents is we asking that when the user give an input city, given like the most popular events that are going to happen on the next 5 days. If you read this prompt correctly, you will notice this is going to require real-time information in order to be able to assess and access the information that the user is asking to. In this example, I connected Bing into this agent. So this agent will have the capability to go out into the internet in order to seek up the information that the user is asking to. If we take a look into the weather agent too, we are asking it to give the weather for the particular city that the user gave to for the next 2 days. Also is connected to, and in this case to Bing to be able to have the capability to answer about the weather. And the news agent is the main orchestrator that is connected to those two agents. So if I go into the playground and I can ask you now, what is the most, let's say, most popular events on Bogota, Colombia for this week? The first thing he's going to do, he's going to take a look into the connected agents that he already has in here. And he's going to choose the best agent to solve the problem that the user is asking to. In this case, give us back 3 events. Now here it comes something pretty important. If we take a look into the agents that have been connected to this main agent, we need to specify something pretty important. The description that is going to activate this agent. So when the user requests popular events into the request, the main orchestrator LLM knows he needs to activate this particular agent. And the same happens for the weather one, which have instructions which have an activation when the user requests the weather. So what is going to be the weather on California? Okay, so as you can see, he retrieved the information using Bing. He used one of the websites that already contains the information of the weather and gave me a human readable description in here. Something that I wanted to show you about the thread is that when the agent executes, he takes the run, he takes a look into the tools that already have attached to. In this case, the tools that he has attached is the two agents, and the agents makes a request given that information. So if you take a look, he sent back the information from the main agent into the secondary one, and the secondary one produces the output requested by the user. So this is something pretty nice that you can see how the threads are actually being executed. So now let me show you something from the SQL perspective too. So from these 3 examples that we have left, we have everything connected to logic apps. So let's take a look into the SQL Server agent in here. So one of the capabilities that we can use when we connect it into the Actions apps, it will be Azure Logic Apps. Within the Azure Logic Apps, you will have the capability to use some templates that Microsoft already have for you. And of course, you can create your unique uh, unique logic app functions to allow the agent to execute those. In this example that we already have in here, this agent is actually connected to a SQL database. So for that, I use a execute SQL query on a database. So this is going to give me the capability to connect in here. I just need to provide the connectivity to my database. I can connect using a user and password, using the Active Directory from Azure. We can connect using a certificate and many other ways. In this case, my agent is already connected to these logic apps, and is also connected to an existing database that I already have in here. So I already gave the instructions to use the query tool to request the information that the user wants to know too. So I'm going to ask him, okay, I would like to know the top 3 products. This is human readable information that I am asking it to. One of the good things, he's going to translate for me this query internally into SQL Server. And from there, he's going to work together without any other additional interaction with the logic apps in order to retrieve the information that I am asking it to. So let's give it a second until it generates the response from the cooldown. Okay, let's say things is a stock. Let me create a okay, let's ask him again. Let's see.
In the meantime, we have a question in the chat. it says, I'm sorry, in the Q&A, it says, do we have to use the table names in the prompts, or is there a place to define I don't know how to pronounce this, aliases for the tables?
Okay, this is actually a pretty good question. So if the user has the capability to, let's say, write the sentence using the right command, the agent will be able to translate those things for us. So for example, take a look into the request that I asked in here. Retrieve all the products. The table that I have into the database is named products. But of course, this is going to be more variable in here. So this will be a perfect example where you can connect multiple agents and have one particular agent that can go into let's say another maybe system, retrieve the, like he mentioned, the alias strap to map the user request into the particular table, enhance the response, and that enhanced response can go back into the logic apps and retrieve the information. So in this example, I asked him to retrieve the information from the products, which is exactly the name of the table in this case. And as you can see, as part of the response, we already have the information back from the database. So in here, using human natural language, he went directly into the database using the logic apps and got all the products that are available into this database, which is deployed on the Azure infrastructure too. So let's see. I can ask update the product with name USB-C with the description. With the description, this is a new product. Okay, already told me the description, blah, blah, this is a new product, so has been updated already. So you take a look into the previous configuration, it says that it was a custom USB hub with a display port, and now it should be, this is a new product. So I'm going to ask him again to retrieve all the products again. Let's see if the operation works as expected too. So yeah, you can see this is a new product. Now if I open the run info again, you will see something pretty particular. He made a request into the logic apps, and at the same time, I will see he took my request in human readable format and transformed that into a SQL query. The same thing for the update property too. Update product set the description into the description that I gave it to, where the name of the product is USB-C. So you can see using logic apps, you can do some things pretty cool, like querying a database using human readable too. So enhancing the instruction of the agents and give like a few shots or a single shot of examples of the things that you need to do, or like the question that you already asked, like using the aliases or mapping the tables in a more meaningful manner. You can easily write an application that can display information into the UI, updating products, retrieving information, listing information, and many of all of those things, just using natural language. Pretty easy, no? It's actually pretty easy to use all of those things. Now there is another example which is pretty similar, and maybe that augments a little bit the response on the question that you already have. The example that we just showed is actually pretty special because it gives us the capability to manipulate mostly any table on the database with the user that we specify to, and select information, update information, delete information, and anything. But if we want to be more granular, we could have an agent that only manipulates, for example, information from one particular table. There is another implementation with logic apps with the example that with this agent in here. We can ask him just to retrieve information to the products table based on the user input. This is going to only work with the products table, but I can ask him, I want to know the products with a quantity over 50. So as you can see, we already got the three responses: a wireless mouse with 150, medical keyboard with 75, and USB-C hub with 200. This particular agent is actually being super specialized and is only going to work with the products table. So if eventually I want to be more granular, have more control of the things we want to do, this kind of implementation are actually more stable in case I just want to keep interaction with a single table. And just to close up, there is in the portal demos we have another agent in here which can make a request to one particular endpoint in here. As part of the connected agents, I also a connected action. Sorry, I have a tool that can make HTTP requests. I already have this API deployed in an Azure Container Apps, and I already set up the configuration to make a request into the API. So I can ask him, I would like to know the weather. This API is only going to return some placeholder information, but it's going to make the request to the information and give me back in a readable format. So if you already work with .NET, this is super familiar for you. This is going to return some random JSON with some random weather and some random dates. But as you can see, if we take a look into the tool info, it made a request to the logic apps. And the good thing is it made the HTTP request for me. I didn't have to go and asking, okay, make a request to this API or anything like that. I just asking, okay, I would like to know the weather. The agent already know these APIs provides the weather too, and it gave me back that too. The same thing for this HTTP request. This not only works with the get property, but also work with the post, put, patch, and many other verbs too. So you will be able to use endpoints to update information, delete information, make partial updates of the information too. And let's say not less important into that, I wanted to show you that everything that I gave an example on the Azure portal can actually be done too using code. This is an example of the code being written in .NET. And in this case, this is going to use the code interpreter to produce an image of an output. So the first thing that I need to do, as any other .NET solution, it will be to install the required NuGet packages. For a project like this, the first thing I need to set up will be the client, which is going to target to the project that I have set up in the AI Foundry. This is the URL for the AI Foundry too. In my case, for security, of course, I'm going to be authenticating using the default Azure credential too, but you can connect using a key. But then again, for security practice in 2025, I fully disencourage you to do something like that. So after we create the client to open the connections and manage everything, we create an agent in here. So as you can see, we only need to give a name to the agent, the instruction, and give the tools that we would like to use. In this case, the tool that we are going to be using is going to be the code interpreter tool definition. Now I'm going to ask my agent to use the code interpreter to produce a graphic. The good thing is that the code interpreter is already have embed capabilities, for example, to use Python internally to produce, let's say, meaningful output for the user based on the user information. In this case, it's going to create a very basic plot, but you will be able to see how the agent can process that too. In here, when we create a run, this is like just asking the question to the agent, and I wait for the answer from the agent in here. Now I'm going to retrieve the information from the agent in here. He gave me the answer too, but more importantly, he gave me back this. I didn't have to write any code, and internally the agent had the capability or was capable to create a NumPy Python code with some of the most common libraries to like Matplotlib to create this content. We didn't have to code anything. The agent took care of the instruction and created this plot for me. Okay, I'm going to delete the resources in here. Pretty similar. Let's see this quick example, I think, to finish up, because we are on time, Camilo, if I'm not mistaken.
Yes. We are a little bit over time, but I'm pretty sure we can just have like 5 more minutes. In the meantime, guys, maybe you can, I just sent you the feedback form to the chat to everyone, so you can fill it out after the session is over. Remember that is there, and we value a lot your opinion about these sessions.
Hey, thank you, Camilo. So something that I also mentioned at the beginning of the demo is that something that empowers the developers to make the agents super powerful or being superheroes is it is the capability to be able to use the programming language that they like to use in order to enhance the agent power. Even when the agent is being executed into the cloud infrastructure and everything, you will have the capability to write custom code, and that agent will have the capability to feed on that code and make custom executions. As you can see, I created a couple of functions tool definitions in here, nothing to overcomplicate it, just to provide an example. I'm going to request this agent to give me a nickname of the city. It's going to give me the weather or the location too. And also I'm going to use the LLM capabilities to give me a fun fact on that city too. So I am connecting this agent to return hard-coded. It's a very split example. The nickname of the city, in this case, Seattle, is going to return the Emerald City. For the weather location, is going to take the input and is going to transfer that into Fahrenheit or Celsius and return that information back to the user too. And in here, I define the action tool. He is going to take the input of the city that I give it to him and also the unit of the temperature that I would like to have using the location that I'm going to send it in here. Something that you notice from the function tool is that you will be able to now to map like a specific structure like JSON data, XML, and many others. So your agent will be more capable to understand a structure. Let's call it a structured data, even if it's unstructured data, but a structured data to know which map is which type of let's say contract is actually going to expect to see. I create another one also in here to get a recommendation of restaurants too. And I attach this tool in here to this particular method just to return some examples of some restaurant that it's going to provide in here. Also, it's going to provide the fun fact in here. And as you can see, I already created different tools. We have three tools. One from the weather, another one from the fun fact, and another one for the nickname of the city. In here, the more important thing is that you will be able to see that we will be able to connect all the tools that we already define in here. The recommendation from the restaurant, the city, the weather, the nickname, and the things favorite for the city too. Here we can define some additional methods to map out which tools have been called, so we can, let's say, see that information on the developer end. I'm going to execute a new run in here. And now I'm going to ask it to give me the information back. So he told me, welcome back to the Emerald City, which is in this case, it's Seattle. He told me the weather is going to be 7 Fahrenheit. There's something to it, it's going to be an unforgettable meal and the fun fact and all the information that I asked it to. Now just imagine those methods. It will be anything that you would like to implement, going into databases, calling other APIs, making some advanced processing too. And the LLM will be able to take that information and, as you can see, provide nice and meaningful information back to the user in a human readable way. All of those things that we saw on the custom tools provide JSON's output, but at the end, the assistant or the engine is going to give me information back that is actually nice for me to see with. Okay, and just to close up with the final demo, which is I think this is actually a pretty cool one. It will be the vector search or the vector store. Something that is actually pretty popular also now these days. It is the capability to be able to search your files and also have the capability to use a rack. Sometimes implementing a rack, it could be a little bit cumbersome because you have to vectorize your information, save that information into a vector database, connect your agent into a vector database to retrieve that information. And every time that you make a request to the vector database, you have to vectorize the information and ask the database for the information and give it back to the agent. Don't take me wrong. This example that I gave is actually pretty good to use with very advanced scenarios and very complex scenarios that require more compute power in here. But if you would like to process is not a huge amount of files, up to 1,000 files for each one of the racks, you can use the vector store in order to save those files, and the Azure AI Foundry with the agent is going to take care of everything. It is going to vectorize the information for you. It is going to save the data for you, the files for you. And every time that you make a request, it's going to take care of vectorizing your request and sending that information to the vector store. So it is going to abstract everything that I just mentioned into a single place. For this demo, I am creating a very basic TXT file with the context. The word apple uses the code 442 to 2345, and the banana uses the code 673457. What I'm going to do in here is going to create this dummy file. I'm going to push this dummy file into the file system of the Azure AI Foundry here. And then I'm going to create a vector store, and I am going to tell him via the code to the vector store, okay, you can use this particular file that I push in this particular step in here. So now the vector store is ready to use. You already have the file, all of the information that are actually working into. Now, what I do in here is I create a file search tool resource and also the vector store. And here the tool that is going to be attached to the user is going to be the file search tool. So as the name suggests, the agent will have the capability to use the search tool to connect to the vector store and retrieve the meaningful information that the user is asking it to. Then again, we create an agent, we attach the tool and the tool's resources that our agent is going to require to. I'm going to create a thread again. And I asking it the document codes for banana and orange in this case. If we go back into in here, we have only the code for apple and from banana. So orange is a unexpected value in here. So let's execute the question to our agent and see the response in here. Okay, and he already told me, okay, the documented code for banana is 67, 32, 57, and there is no documented code for orange in the available file. If you need more information, please let me know. Okay, so I think this summarize the examples. So even they look pretty simple. This is the kind of thing that you can leverage on the AI Foundry to build super smart and super powerful agents using the Azure infrastructure. Okay, thank you. There are any questions by now?
Guys, if you have questions, you can raise your hand and I will give you permission to speak, or maybe just use the Q&A feature and we'll make sure to answer them all. Guys, if maybe you have a question later on, you can Slack it to me or maybe send it to my email if you're not part of GAP. Thank you again to Santiago for sharing all his valuable information with us today. And remember, for those who are part of GAP, that we are still in the AI agent saga, and we have some more activities for you this week. So thank you again, Santi, and see you in the next one. Bye-bye.
Okay, thank you everyone. Have a good one.